We turn now to the subject of extreme values and critical points. Um, and this is, by the way, the start of chapter 4 if you're following along in the Thomas Calculus textbook. So let's start by supposing that f of x is defined on some domain D. We're going to be very general about what the domain is. We're just going to call it D and not really say much about it. Let's also suppose that C is some point in D. So in other words, let's imagine that the domain of the function is, let's say, this interval a to b. What this symbol, this little sort of e written in a curved style means, it means element of. So I'm saying that C is an element of the domain D. In other words, C is just part of the domain. So we say that f of C is an absolute maximum of f on D if f of c is greater than or equal to f of x for all x in the domain. In other words, if I plug in any value in the domain and f of c gives me the highest possible value of all possible values of f, then we say that f is the absolute that f of c is the absolute maximum of f on that domain. And then we flip that statement around and similarly define. Apologize, it looks like I had a typo in here, and similarly define the absolute minimum value to be f of c if f of c is less than or equal to f of x for all x in the domain D. This is, of course, a lot of words, and I understand that, so we're going to do an actual example and hope that that makes it a little easier to see what's going on. As is often the case, the example is a lot less scary than the formal definition. So let's let f of x equal x squared on the domain that is the interval -2 to 1, and this is the closed interval, so it includes its endpoints. Um, so let's find the absolute minimum and absolute maximum values of f on the domain. What we can see is that on the domain, this is of course the parabola x squared, but it's restricted to the domain -2 to 1 rather than being defined for all real numbers. So what we can see is that the highest value that the function attains on this interval is 4, and the lowest value that it attains is 0. Because of course, remember, we're looking at the y values, not the x values. So we would say that what we'd say is that we'd say that 4 is the absolute maximum of f on the domain -2 to 1, and 0 is the absolute min of f on -2, 1. There we go. So that's, as you can see, it's sort of easier to work with a real example to understand what's going on. And by the way, and I'll bring this up a little bit later as well, when we talk about absolute mins and absolute maxes, we're talking about the y values. So we're not. It's certainly correct to observe that the number -2 has some meaning in this problem, but what we would say is that -2 is the location of the absolute max, and similarly, sorry, not 1, 0 is the location of the absolute min. It also happens that 0 is also the absolute min itself, but the point is that it's the x value 0 that tells us where the minimum y value occurs. It's just a complete coincidence that the minimum y value there also happens to be 0. A little easier to see in the case of the max in this example. 4 is the maximum value of f. -2 is the x value where that maximum value happens. So a little terminology here. We're going to use the term extremum or extreme value. Extremum is Latin. This is a field of this is an area of math where Latin tends to appear quite often. So you can use either term, extremum or extreme value. You should know them both, though. Where this is the extremum or extreme value is either a maximum or a minimum. And these terms are all pluralized in Latin by changing the um to an a. So for minimum, maximum, and extremum, we write the plurals minima, maxima, and extrema. For example, if I had a function that had, let's say, well, we haven't yet gotten to why there would be more than one maximum, so I'll leave that for later. But these do have plurals. So